Happy learning! Today we're going to talk about derivative formulas. Okay, so in the last video, we learned about the derivative and how to compute it using the limit definition of the derivative. And that's a kind of a slow way to find the derivative. So today we're going to learn some formulas for evaluating derivatives more efficiently. All right, so we're going to start off with what's known as the power rule. All right, what does it say? It says if f of x, so if our function is equal to x raised to some power, then f prime of x equals, we bring the power in front and we subtract 1 from the exponent. So the derivative of x to the n is n x to the n minus 1. All right, let me show you a few examples. If f of x is x to the fourth, f prime of x is, we bring the 4 in front and subtract 1 from the exponent. It's literally that easy. So we don't have to write out the limit as h goes to 0 of f of x plus h minus f of x all over h. We just bring the power in front, subtract 1 from the power. All right, so try these next two on your own. And let me know in the comments if you're able to get them. Okay, so find the derivative. First one, actually let's do 3. I said 2? Let's do 3. F of x equals x to the negative 2. Y equals x. G of x equals x to the 1/3. All right, so pause the video. Let me know in the comments if you're able to solve these. If you could solve these, you're in good shape. All right, so let's work through these. For A, f prime of x equals, bring the power in front, negative 2, x to the negative 2 minus 1, negative 3. All right, I know some of you had the exponent as negative 1, but it's negative 2 minus 1, which is negative 3. All right, what about this? The exponent, so here y prime, the exponent of x is 1. So we bring the 1 in front, and we subtract 1. It's 1x to the 0. What's x to the 0? It's just 1. Remember, the derivative is the slope. Okay, so the slope of the line y equals x is 1. So we should have gotten an answer of 1, which we did. And now finally, we have a fractional exponent. But have no fear, the rule still applies. So g prime of x equals, we bring the power in front, and we subtract 1 from this power. 1/3 minus 1 is negative 2/3. All right, so that derivative of x to the 1/3, or the cubed root of x, if you will, is 1/3 x to the negative 2/3. All right, the next rule is the constant function rule. I'm not sure why it gets its own name, because it's a very simple rule. It says if f of x is a constant, okay, remember, the derivative is the slope. A constant is a horizontal line. Its slope is 0. Okay? So if f of x is c, then f prime of x is 0. The slope of a horizontal line is 0. Okay, a few more. If f of x is some constant times g of x, so if our function is a constant times some other function, then the derivative is that same constant times the derivative of that function. Basically, this is saying ignore the constants out in front and just make sure to multiply by them at the end. So let's take a look at a few examples. Find the derivative. So first, we'll look at f of x equals 4x to the fifth. And next, which will be a little bit tougher, g of x equals 5 over the square root of x. All right, this one, in my opinion, is pretty easy. Easy once you see how to do it, but it might take a little bit of, heaven forbid you have to think a little bit. It might take a little bit of thinking. All right, so let's start with A. So what does our rule say? Our rule says ignore the 4. We'll just deal with it at the end. So we bring the power in front. So it's 4 times, bring the power in front, 5, x to the fourth. 4 times 5 is 20. All right, so the derivative of 4x to the fifth is 20x to the fourth. How the heck do we deal with square roots? And how do we deal with denominators? Well, let's rewrite our function as 5 times x to the negative 1/2 power. Right? The negative in the exponent says that our x was originally in the denominator. And the 1/2 is another way of writing the square root. All right? And so now this function, it's going to be easy to take the derivative of. We bring the power in front. So g prime is equal to negative 5/2, right? 5 times negative 1/2 is negative 5/2. X to the negative 1/2 minus 1 is negative 3/2. Okay? And so that's the derivative of our function. Let's look at one more set of rules. There are plenty of derivative rules. We'll talk about derivative rules for products and quotients and the composition of functions. You know I love composition of functions. We'll talk about derivative rules for those, but we're not ready for it yet. We're going to start with an easy one now. Sum and difference rules. What are the sum and difference rules? It says if f of x is equal to g of x plus or minus some other function, h of x, then f prime of x is equal to g prime of x plus or minus h prime of x. If we have a bunch of terms separated by addition or subtraction, this rule says take the derivative one at a time. So let's find the derivative of the function x to the fifth minus 2x to the third minus 4. All right, and so this is really straightforward. If you believe the sum and difference rule, which you should, it's a fact, we're just going to take the derivatives one at a time. All right, what is the derivative of x to the fifth? It's we bring the power in front and subtract 1 from the power. What is the derivative of 2x to the third? So we're going to keep this minus here. The derivative of 2x to the third, we bring the power in front. 2 times 3, 6. And subtract 1 from the exponent. And now what is the derivative of 4? The derivative of a constant is 0. So we could write plus 0, or we could just not, because it's just adding 0. And this is the derivative of our function. 5x to the fourth minus 6x squared, and then plus 0. All right, let's look at an example. This one's a little bit challenging, but I believe in you. Find all points on the graph of the function f of x equals x to the third plus 3x squared minus 45x plus 4. All right, so here's our graph. So find all points on the graph where the tangent line is horizontal. Okay, I'll give you a hint. There's 2 of them. Okay, so pause the video, try to find these points using the techniques we've discussed today, and then let me know in the comments if you're able to solve it. All right, one of these days, the year could be 2032, and somebody's going to comment saying, "Hello from the year 2032, I solved this problem, and here are the points." Okay, so how do we do this? What does it mean for the tangent line to be horizontal? It means the tangent line looks like this. Its slope is 0. Okay? So we want to find all points on our graph where the derivative is 0. So let's take the derivative, and we're going to set it equal to 0, and then we'll reevaluate from there. All right? So let's take the derivative, f prime of x. We're going to bring the 3 in front. Subtract 1 from the exponent. So 3x squared. The next term, plus 6x to the first minus 45x to the 0. X to the 0 is just 1, so minus 45. And then the derivative of 4 is 0, so we don't have to include that. Right? And so our goal is to find when the tangent line is horizontal, when the slope of the tangent line equals 0. All right, so we could solve this. This is a quadratic equation. We could solve this by using the quadratic formula, or we could try to factor. And I'm going to factor here. Notice each term in this quadratic is divisible by 3. So I'm going to divide both sides of the equation by 3. This gives us x squared plus 2x minus 15 equals 0. All right, and now we could factor this pretty easily. This gives us x plus 5, x minus 3 equals 0. It gives us these x values. And so you might be thinking, I'm done. I got 2 x values. You said there was 2 answers. And I would say, wrong. Find all points. A point has an x value and a y value. We only have the x values, right? So we need the y values as well. So the way we get the y value is we sub x into our original function, right? Our original function gives the y values. You do not sub it into the derivative. The derivative gives slopes. We want the y value. The original function gives the y value. All right, so we sub x equals -5 into our original function. So just type it into a calculator. You get the value of 179. And we do the same thing with 3. And we get the value of -77. So what are the points on our graph that have a horizontal tangent? Is the point -5, 179, and the point 3, -77. So roughly speaking, our graph would look like something like this. So we'd have one horizontal tangent up here and one horizontal tangent down there. So this is just a rough sketch of the graph. But since we found the derivative was 0 at this point and this point, we have horizontal tangents there. OK, let's look at an application. All right, so suppose that the manufacturer of a product knows its revenue function. OK, so suppose that we have a revenue function given by 1,500x minus 0.02x squared. All right, so this is our total revenue function if we sell x units. So this is the total revenue from the sale of x units. What I want us to do is find the marginal revenue at x equals 500. All right, remember, the marginal revenue is how much our revenue increases by that sale of the next unit after 500. OK, so let's actually do two things. So we'll find the marginal revenue. We know the marginal revenue is the derivative of the revenue function. And then what we're going to do is find the actual change in revenue So how much does the revenue actually change? This marginal revenue gives us a very good approximation, but we could find the actual change in revenue from x equals 500 to x equals 501. All right, so marginal revenue is the derivative of our revenue function. So this is a, r prime of x. What is the derivative of our revenue function? Derivative of 1,500x is just 1,500. Minus, we bring the 2 in front, 0.04x to the first. This is our marginal revenue function. And so we could get the marginal revenue at 500 by just subbing that in for x. If we sub in 500 for x, we get the value of 1,480. So So this says if we sell that next unit, we would expect our revenues to increase by about $1,480. We could find the actual change in revenue by doing R of 501 minus R of 500. Right? This is the total revenue after 501 sales minus the total revenue after 500. It tells us how much we increase by that 501st sale. So we plug this into our R function. That gives a value of $746,479.98. And then we subtract off when we sub in 500 into our R function, which is $745,000. All right, and we take this difference, and so this is the actual change in revenue. Our first answer here was an approximation, but you saw how easy it was to get. The actual change in revenue is $1,479.98. Okay, so hopefully this convinces you that the derivative, which we saw was very easy to compute, gives a very good approximation for the actual change in revenue. Okay, and so what did we learn today? We learned the product rule. Bring the power in front. Right? Bring the power in front. Subtract 1 from the power. And if we're separated by pluses and minuses, just go one term at a time. Okay? We will learn how to deal with products, quotients, and compositions. But we're not ready for it yet. All right, so that's what we'll do in the next video. So let me know if you liked today's video. Let me know if you have any comments or thoughts, and I will see you in the next one. Bye-bye.